Good afternoon, everyone. Thank you to Ventsim for the opportunity to present to you today, and thank you all for still being here as well. So as introduced, I'll be talking to you about using RPM MinePlanner to generate a Ventsim model. And first of all, I'll start with introducing who RPM Global is and what MinePlanner is as well. So RPM Global was established in Australia in 1977 by Ian Runge. So some of you may have known us as Runge, and we are now RPM Global. Our goal is to advance the mining industry by delivering safer, more efficient and more sustainable operations. We have a diversified client base ranging across global resource leaders and commodity leaders, covering coal and energy, iron ore, gold, copper and metals, oil sands, potash and diamonds. We also count global contractors, OEMs, JV partners and financial institutions in our client base. We're focused on the mining industry alone. RPM operates in 125 countries, providing advisory and consulting services and software solutions that span the entirety of a mine's life. So some of the software solutions you may have heard of include Xeris, AMT, HallSim and XPack. That's just some of them. Today I'll be focusing on the integration between MinePlanner and Ventsim, and I'll also introduce plans for another of our products, the SOT, the Schedule Optimization Tool, and its future work with Ventsim. So XPack revolutionised mine planning in the 1980s with its heuristic scheduling algorithm to help planners identify practical, efficient mining sequences with an emphasis on meeting production targets. XPack solutions progressed this further, delivering a 100% script-free mine planning package that continued to hone the features available to planners, specifically to deal with challenges unique to each mining operation. RPM MinePlanner is the most recent evolution of this powerful scheduling engine, combining 11 of our commodity and mining specific solutions into an enterprise-enabled mine planning package. And today I'll be demonstrating the integration with Ventsim, using examples from our underground metals, underground coal and underground potash life of mine schedules. A connected development network is fundamental to underground mine planner schedules. We use the centre lines to build a mathematical model of the mine that is then used as the basis for many of the mining rules and haulage calculations. All development must be connected centreline to centreline, and all planned development must have a valid connection back to actual development. The centrelines also carry information about development heading dimensions and names, and this information dovetails nicely into airway information for Ventsim. So as mentioned, MinePlanner can generate schedules for multiple mining methods and commodities. So here you'll see some life of mine schedules that have been completed for an underground metals mine, underground potash and underground coal. And I'll be using these to demonstrate the integration with Ventsim. MinePlanner follows an organised workflow of defining and updating geology, production shapes, access networks, equipment information, operating parameters or mining rules, and post-mining blends to generate mine schedules across short, medium, life of mine and strategic planning horizons. So after we've run the schedule, this is the screen we use to set up the export to Ventsim to generate a Ventsim model. You can see down the left-hand side, we can see the workflow. We've run the schedule already, and so now we're ready to send to Ventsim. So first of all, filling in some general fields for what the name of the Ventsim model is that we're going to create. And it is actually a Ventsim model. It's a VSM file that we will be generating. If there is a template available that might, for example, contain some fan information, we can define that, but it's not essential. Defining, obviously, the units, and there's an option there to open Ventsim as soon as the export's done. We send airway names, and then we also have options for whether we want to send airway types, and if any of those airways should be organised into primary and secondary layers. These are options, they're not compulsory. There is also an option to auto-close dead-end stubs, and we can define a distance there. This is, as long as this distance is a distance from the nearest intersection to that dead-end stub. So as long as that is within the specified distance, it will auto-close. The final option you'll see here on the screen is for sending staging information. Users can select a unique or shared staging type. Unique meaning that an airway will be created for each stage that the centreline occurs in, and shared staging means that only one airway will be created and shared across all stages that the centreline occurs in. Scheduling periods can be nominated as key stages, for example, the 1st of January for each year, as well as key scheduling events, such as the commissioning of a new shaft or the decommissioning of a retired shaft. So once we execute the step, we're generating a VSM file, as I said, and we can open Ventsim. And we send the airways to Ventsim. Airways are created in Ventsim for each of the centreline segments associated with each of the mining records. The values associated with the mining records can be assigned as attributes of the relevant Ventsim airways, and since the centreline network is a connected network, then the airways will form a connected network in Ventsim. So here's an example of some of the information that's been sent from MinePlanner to Ventsim. So up the top here, we've got the airway name. It's a bit small, I know you can't see it, but I'll be happy to show you afterwards if you'd like to find me. We've got here all of the stages so I've got this airway up here at the top of the razors selected. And so on the second line, highlighted line here, we've got all of the stages that part of the raise occurs in. We've got the tunnel type, the airway type, the airway shape and diameter. And down here we've got the airway type and whether it's the primary and secondary layer information. The primary and secondary layer information you can see here is automatically populated in the relevant preset tables, and that comes directly from MinePlanner into those tables. So here we have an example of an underground coal mine that's been sent from MinePlanner with various staging information. You can see, sorry if I go back, you can see the staging list has automatically been populated as well with those stages sent from MinePlanner. This one is an underground potash mine. Just as with the underground coal and metals mines, the model includes user configurable stages, airway names and properties, layers and lengths. So that's what we've done so far. What have we got planned next? At the moment, reference layers still need to be manually imported into a Ventsim model. So we plan to continue to expand on the existing integration using the Ventsim API to bring, for example, those reference layers in automatically. And also, if there's further information from the schedule or from the design data that can add further definition to the Ventsim model through attributes, we'd like to bring those in as well. In MinePlanner, we are currently working on automatically identifying the location of air crossings, underpasses and stoppings from the design. Users will also be able to remove or modify their auto-generated components, as well as insert new components. Once this feature in MinePlanner is complete, we plan to share this information with Ventsim as well. Via the API. So after a schedule has been updated, we'd also like to be able to read an existing Ventsim model and, where relevant, change the staging to represent the new schedule without modifying the components of the schedule. And as I mentioned on the previous slide, continue to build on the existing integration. So, proper ventilation is critical for underground mines to operate safely, yet it is often not adequately considered early in the mine planning cycle. So here we have an example of the results of a strategic planning exercise where the schedule has been optimised to achieve a higher NPV schedule using equipment and plant constraints, metal recovery and the financial inputs. We can see from this animation that several areas of the mine are being opened at the same time, making ventilation very challenging. So the need to account for ventilation early in the planning cycle motivated the development of the ventilation constraint module. This work started as a research project by Morocco that I think several people in the room are familiar with. The initial ventilation constraint module output from this research project is now owned by RPM and is part of the SOT suite. So at the moment, we're already sending information from RPM MinePlanner to SOT, scheduling information, and we're also sending airway information to Ventsim. Simultaneous optimisation of the life of mine schedule and ventilation system is still a work in progress. The ventilation constraint module generates ventilation constraints that are then applied during the schedule optimisation process so that each schedule adheres to airflow-based equipment constraints for each district and at each stage of the mine life. Adhering to these airflow-based constraints, as well as other constraints related to the project, SOT is then used to maximise the MPV of the long-term schedule. We have Laurie Farver, who's the product manager of SOT here today, who will be able to talk to you in more detail if you are interested in the work we have planned for the ventilation constraint module. So thank you for your attention. I hope I've shown you something to pique your interest, and if there are any questions, I'll be happy to take those. Thank you.
Thank you, Helen. I guess before we go into questions, I think you answered a few of the questions asked earlier about integration and, you know, designing company and making work in that sense. So I think we had a very active relationship here and lots of new development being made in that sense. And unfortunately, one of the last sessions, so if you want to catch up with Laurie before she goes, she's at the back over there. So don't hesitate to go ask her a question about applying ventilation to design. So, questions? Who here knew about RPM Global before today? Not many, long story short. So
That's more than I thought, so thank you.
Any questions in the end? No? Well, thank you. I think you piqued their interest anyway, so
Thank you.
it's good. Thank you.